So we just saw some parameterizations. We were given x equals some formula involving t, y equals a formula involving t, and then we saw what it looked like. Now let's go in reverse. Now the picture is described here in words. Line segment starting at 10, 3 and ending at the point 2, 40. And then we should now provide x equals a formula involving t and provide y equals another formula involving t. It's convenient for line segments to have the parameters endpoints be t equals 0 and t equals 1. That is, we're going to just, by convention right now, just choose a way to write this. There are many ways to do it, but choose a way to write this so that 0 is less than or equal to t is less than or equal to 1. So when t is equal to 0, we want the point 10, 3. And when t equals 1, the last value of t we're going to look at, because t only goes up to 1, we want this point 2, 40. Right? So starting at, well, if t starts at 0, then we want to get this point. So we would like, when plugging in 0 to the x formula, we need to get the number 10. And when plugging in 1 to the x formula, we need to get the number 2. When plugging in 0 into the y formula, we need to get a 3. When plugging in 1 into the y formula, we got to get the number 40. So to create a straight line segment, just a line segment, the value of x should really change from 10 to 2 at a constant rate, and the value of y should change from 3 to 40 at a constant rate. I mean, just nice and gradual, no funny business here. And here's a nice way to do this. This is certainly not the only way to do this, but this is real nice. The change in x will stick in the order of the new value minus the old value, so 2 minus 10 or negative 8. Same deal, change in y here is 37. And then here's one possible parameterization of the line segment. X is equal to, well, we need to start at the number 10. Okay, so start at the number 10, but eventually we need to make this full change. You know, the change in x eventually needs to be negative 8, but that change should be gradual. So as t is equal to 0, and then t equals, 0.1, and t equals 0.2, and then eventually t equals 0.5 in the middle, and then at the very, very end, t is equal to 1, that should represent the full amount of change here. Same sort of deal with y, so the starting y value is 3 right here, and then eventually there needs to be a change of 37. So by the time t is equal to 1, a change of 37, and you can verify that everything works about this. So why does this really work? Let's think about it. Let's just, the minus in the x formula makes it a little more confusing to look at, so let's just look at the y formula. Talk about why does the y formula work, and then you can basically say the same for the x formula. So, well, look, y is equal to 3 plus 37t. Well, plug it in. Plug in t is equal to 0. Then you get y is equal to 3. When you plug in t equals 1, you get 3 plus 37 times, well, 1, right? So you get 40. You get this y value 40 that you want. And the key thing about what's going on here is you'll notice that the y value, that y prime, the derivative of y with respect to t is constant. If you were to differentiate 3 plus 37t, with t being the variable, you're just going to get the constant 37. So this change is very gradual. It's the slope is a constant 37, and the same story goes for x. So as t moves from 0 to 1, sort of unit by unit, and I get it's only by 1 full unit, but even by 0.1 unit at a time, then the amount that x changes and the amount that y changes is all proportional. And that's why we end up getting a straight line segment. Okay, so we're going to actually revisit this question, but look at it another way. The same question, here's a different approach. Some of you might prefer this approach. It's, I think, good to have both in mind. Consider this more as a game of tug-of-war now between the points 10, 3 and the point 2, 40. So when t is equal to 0, the first point should be fully winning the tug-of-war, and when t is equal to 1, the second point ought to be winning. So when t is equal to 0.4, then we want the first point to be winning by a certain percentage and the second point to be winning by a certain percentage. I think I actually do have the percentages flipped here. It should probably be 60%, 40%, but just conceptually, I hope this is okay. And so what we'll do here is say there's the number 10, there's the number 2. Those are the two x values we're working with. And in the beginning, when t is equal to 0, we want 10 to have all the contribution. So when t is equal to 0, well, 1 minus 0, yeah? So this part in parentheses, 1 minus t, oh, just want to select that. Can't seem to quite do it. That part will end up being 1. And again, when t is equal to 0, well, this part completely drops out. Then on the flip side, when t is equal to 1, the 2 has full contribution because it's 2 times 1, whereas when you plug in t is equal to 0, 1 minus 0 has no contribution. Okay, same sort of deal over here, right? So you'll examine actually that when you have x is equal to 10 times quantity 1 minus t plus 2t, we're trying to say that we're getting all of the 10 and none of the 2. And here this is one way to write down what we get when we plug in t is equal to 0. When t is equal to 1, you get none of the 10 and all of the 2. When t is equal to 1/2, you end up getting half of the 10 and half of the 2. And same general comment for y. Just a thing to pay attention to if you've taken or are currently taking linear algebra. If not, don't worry about this. There's so many connections to linear algebra and 225 that I have to mention them, but if you haven't taken these other classes, don't worry. So just a little bonus to help you out if you're in linear algebra. You could think of 10 times 1 minus t plus 2 times t as being some kind of a linear combination of 2 and 10, with the weights being 1 minus t and t. All right, so let's parameterize the line segment from 4, 55 to 12, -3. The first line of the answer is already showing. We computed the change in x to be 8, the change in y to be -58. So then we'll end up with the parameterization x equals 4 plus 8t and y equals 55 minus 58t, t going from 0 to 1. A second answer is that tug-of-war style answer. It looks like this. I know that these two answers rather look a bit different, but if you were to distribute the 4 here and distribute the 55 and simplify and so on, you'd see that these really are in fact the same. So please make sure that you understand both answers. Verify, for instance, what point you get when you plug in t is equal to 0. Verify what point you get when you plug in t is equal to 1. Those are the minimum things to check, but also just check what happens when you plug in t is equal to 1/2. And how about halfway between the t values of 0 and 1/2? See what happens when t is equal to 1/4. Like really plug in to either over here or over here to really just go through the arithmetic. The arithmetic, of course, here is not hard, but going through the arithmetic really helps clarify what the heck is going on with parameterizing line segments.